So this is on how to use automation with Spectrum. And with Wireless Protocol Suite, you can use automation to capture the spectrum of the environment and then to also export the spectrum from a capture. I'm going to focus on the exporting of spectrum from a capture, but if you're interested in recording using automation with a Spectrum, if you look at our automation server protocol manual that comes with, it's included with the Wireless Protocol Suite installation, we have a section on what you want to send for a command. It's basically to send a Spectrum on command when doing the capture. And then also you can then set the interval of what your spectrum snapshots are. So for capturing the environment, do you want to do that in 20 microseconds or 200 microseconds, depending on your needs of the balance of having either a lot of spectrum data, or if you're just interested in a overall look at the environment but don't need to capture rapidly occurring events, you can use a longer snapshot window, which would mean less data in your capture file. So assuming that you've already captured with Spectrum, I'm going to show the second part, and this is the analysis part. And when you have Spectrum, being able to have automated analysis is useful to look for anomalies, to characterize devices. And in this case, we'll look at an anomaly from a microwave oven. And so the first thing to do to export the spectrum from a capture is to load the automation server. So load that here. Now I have a virtual machine set up. I'm using Visual Studio Code with Jupyter notebooks. And so I'm going to just load some basic, so we'll just run these cells. To run the first cell just sets up some of the information. The second cell the critical components, these are constants I'm going to use later, but things like what's the IP address of where this automation server is running and the port and what the capture technology, but we don't really care about that because we're going to open an existing capture. And so I am specifying that the Windows name of the capture, and then I'm going to specify what we want the Spectrum file to be exported from that capture. So these are just specifying variable names. Now going to open the Wireless Protocol Suite, so passing in those parameters like the IP address and the port. And this is just code that wrappers code from other demos that we've talked about where we've actually gone into the back and forth communication. It's text-based communication where you're sending start FTS and then waiting for a succeed command. And so it just wrappered that information up to simplify this demo. And so when we go to load this, so it's just loaded Wireless Protocol Suite. It hasn't loaded a capture yet. And we can see that if we look at the automation server that's communicating between the notebook and the Wireless Protocol Suite, we can see what we've sent and what we've received. So there was an initialization. We had the is initialized. This is just summarizing the communication that went back and forth with those text-based commands. And then I'm going to open that file, which is this microwave power oven. And so we're going to open the capture. And we'll see that Wireless Protocol Suite will now open that. And we can also see the communication here. And so the open capture file succeeded. We can see that it's now open. File name's up here. And we're going to export the spectrum into this data directory. So I'll just move that over here. And so we'll export the spectrum from the capture. And the file name should be the microwave power oven, CSV. And so that's right there. And I'm exporting the entire capture. And so it'll export all of the spectrum. And then once this succeeds, we're going to close down WPS, and then we're going to go into the analysis of this file. And so we're going to just show, and this will be just a demonstration of the motivation of exporting the CSV file and one of the reasons that you would want to do that. And specifically, we're going to be looking at the spectrum for being able to characterize that microwave oven interference. And so looking at that. So let's see, let me check on this. Okay, so that's done. And now we can close Wireless Protocol Suite. And so this would be, now that the data is accessible, that we have is the CSV file, we close that. And if you wanted to, we're also capturing the logs so that you can see the same type of information that you're seeing over here. So if we want to look at this would represent some backend processing that being able to look at the interference from the spectrum. So now we're going to read this exported file, and I'm reading this from Linux because I have a drive mapping set up that goes between Linux and the Windows machine. So this drive here is this file right here. It's just mapped to both. And so we loaded in the shape and then just truncated it for this. This would be the channels and the time, but I've truncated that for display purposes. And so this is the microwave power spectrum. And we have another video of using the same capture file with the where we look at it from a UI perspective, if you want to see what that looks like in the Wireless Protocol Suite. But basically what we have here is time along the horizontal axis. These are the frequency bands. And then this is the microwave oven at 60 hertz, a 16 millisecond period, which is about 60 hertz frequency between these transmissions of the microwave oven. So if we were wanting to, let's say, do some processing to characterize it, that could take this, could do some image processing, and so I'm going to just normalize the data here. And basically the idea is I want to be able to get a mapping of what a parametric representation, so fit a curve to these interference patterns to be able to do more analysis or use it for modeling in an environment. And so we'll just, using just the Python tools like NumPy, and actually, and we'll see an interface to OpenCV. This is OpenCV and a Python wrapper around that. That's a computer vision library. So what we're doing is we were thresholding the data to capture the fact that these tend to be higher, and then we're going to mask off the bottom part and the top and bottom part. And when we do that and then plot it, this will now be transformed here, and then actually mask off, and then we'll do that using erosion and dilation. And so we can then see that the cleaned up microwave oven frequency is shown here, and it's thick from doing the morphological operations. So we want just a thin line so we can do a curve fit to it. And if we do that, that would be the thin line using skeletonization. And all of these are using open source tools here. And then actually looking for contours and then fitting with a B-spline. And so now once you have the B-spline overlay, you could either fit that to a polynomial depending on how you want to represent model this. And so this is just a toy example showing the advantage of being able to use automation to export spectrum in a common CSV file so that you can then apply whatever backend tools that don't need to be knowledgeable of the wireless protocol suite file format to then do processing using standard image and statistical processing to be able to do what type of interference examination or other spectral work that you want to do.